Alright, so number 27 asks us to find all pairs AB of integers with A is greater than or equal to B, which is greater than 0, which satisfy the equation AB equals 14 times A plus B. And the only strategy that works here that I found is to guess and check, but this isn't particularly easy to guess and check with, so let's get it in terms of one variable. So let's distribute AB equals 14A plus 14B, 0, 14A minus AB plus 14B. Right? So now 0 equals A times 14 minus B plus 14B. So A equals negative 14B over 14 minus B, which is 14B over B plus minus 14. My bad. Alright, so what can this expression tell us? Well, we know that if A and B both have to be positive, then B has to be greater than or equal to 14. But if B equals 14, right, that's undefined, so we can't divide by 0. So we know that B has to be greater than 14. So now we can just start guessing and checking. Well, can B equal 15? Well, if that was the case, then 14 times 15 over 1, 210. So yeah, because it's an integer, B can equal 15, and when it does, A equals 210. So 210, 15. Well, can B equals 16? A equals 14 times 16 over 16 minus 14 is 2. 7 times 16, 7 equals 42, so 112. Now we have 112, 16. I'm going to erase these to give myself some space. Well, can B equal 17? Well, let's see, does it give us an integer? If B is 17, A is 14 times 17 over 3. 14 times 17 is 238 over 3. Well, let's check. We can tell if a number is divisible by 3 if the sum of its, if each integer is equal to, is a multiple of 3, right? Sorry, a little bit it's inside there. So 5 plus 8 is 13. 13 is not divisible by 3, so B can't equal 17. Right, that's off. Can B equal 18? Well, let's see. 14 times 18 over 4. 14 over 4 is the same thing as 7 halves. So 7 times 18 over 2. And we can divide 18 by 2 as well. So 7 times 9. 63. Let's save a little bit of legwork there. So B can equal A can equal 63 when B is 18. And you keep going along that way, and you'll eventually find that B can also equal 21 and 28. Right, so when B is 21, A equals 14 times 21 over 7. 14 over 7 is 2. 2 times 21, 42. So 42, 21. B equals 28, and A equals 14 times 28 over 28 minus 14 is 14. So this just equals 28. So 28. Alright. Well, can you keep going? Well, you could, but if you kept going, we notice the pattern here. B gets larger as A gets smaller. So if you kept going, B would actually become greater than A. So by the constraints of the question, these are the only pairs of integers that satisfy AB equals 14 times A plus B. So these over here are. And you really do just have to guess and check. There's no real pattern that I found. You just got to tough it out. So, thank you.